So since there doesn't seem to be any questions, which I'm taking it as good news. Just so that you know what is going to be on the exam. So you will have one probability question. So you will have one probability question where you're working with a frequency table, and I will ask you the probability of certain things occurring. You will have one question about reading normal distributions. You will have questions about starting with a raw score and getting a percentage. So starting with a raw score and then using the normal distribution, the unit normal table, ending up with a percentage of the or proportion of the distribution. You will have a question where you are given a percentage, and then once again, using the unit normal distribution table, you end up with a raw score. And then the rest of it is all going to be hypothesis testing. So there will be 4 questions that will look exactly like the practice questions that I gave last time. So they will look exactly like this. So there's going to be 4 of those. The only difference is that for practice purposes, I made the comparison distribution here very evident in terms of that's the distribution that you will use. In the exam, it will be in the paragraph itself. So it will say something like the population of students have a mean of 34 miles an hour with a standard deviation of 6.34. The comparison distribution has a mean of 34 and a standard deviation of 2.59. So that's the only difference. It's just going to be not as in your face and bold in terms of which distribution you need to use. It's still going to be the comparison distribution, but you will still be given the information for the null hypothesis. You just choose the sign to make it correct. You will be given the information for the research hypothesis. You just choose the sign to make it correct. You have to look up your Z critical scores, your lines in the sand, from your unit normal distribution table. You have to calculate your sample Z score by taking your sample mean and using the comparison distribution to calculate a Z score. And then you simply choose whether you accept the null hypothesis and reject the research hypothesis, or reject the null and accept the research hypothesis. And just bear in mind that you are not allowed to hedge your bets. If you want to get points for part 5, you need to accept one and reject the other. If you put accept for both, you don't earn half points. You get it completely incorrect. So, well, step 5, you get it incorrect. So there will be points for the null hypothesis for the step 3, step 4, and step 5. For all the steps, there'll be points for each of those. And you will be doing 4 of those. They will be one-tailed tests. There will be 2-tailed tests. There will be alphas of 0.05. There will be alphas of 0.01. So be sure that you know all the steps for that. And if you are clear on all of that, then there will be no surprises. And we should be seeing a lot of 100% on this upcoming exam. And that is typically my experience in this course, that as we go further and further, once statistics kind of snaps to in your mind, it's just, hundreds from there on out. So again, if any part of that, you're thinking you're a little shaky on, let me know. We got time today. But if not, that's awesome too.
Would it be too much for you to just do a whole question?
No, it would not. All right. So do you have a preference for one? Okay. Which one?
Just like one of those practice ones.
Well, yeah, that's what I wrote.
Okay. Well, we've done 2-tailed before, so let's do the 1-tailed one over here. All right. So let me zoom in on this. Zoom a little bit more. All right, so it goes in 1974. Loftus and Palmer conducted a classic study demonstrating how the language used to ask a question can influence eyewitness memory. In the study, 15 college students watched a film of an automobile accident and then were asked questions about what they saw. The students were asked about how fast were the cars going when they smashed into each other, The average speed reported by the 15 students was 40.8 miles per hour. However, for students that were asked about how fast were the cars going when they hit each other, the estimates of speed for the population of students is 34 miles an hour with a standard deviation of 6.34. Do the results indicate a higher estimate of speed for the smashed into group? Use a one-tail test with an alpha of 0.05, and the comparison distribution has a mean of 34, same as the population, but it has a smaller standard deviation of 2.59. All right, so step number one for the hypothesis test, what is the null hypothesis and the research hypothesis? So one little trick that you can use, or two tricks that you can use for this. First off, if it's a two-tailed test, if it says here, do a two-tailed test with an alpha of 0.05, your null hypothesis is always equals, your research hypothesis is does not equal. That's the more straightforward case. The two-tailed, as soon as you read two-tailed, you know that for the null hypothesis it's equals, for the research hypothesis it's not equal. For a one-tailed test though, you have to choose the direction. So in this case, we would look back up here and see what question they're asking, which direction they want. And it asks, do the results indicate a higher estimate of speed for the smashed into group? So for the one-tailed test, always do the research hypothesis first, because that's what we are looking for. Is the research indicate a higher estimate of speed for the smashed into group? So we want to know if the mean for the smashed into group is greater than the mean for the hit. That's the question that they're asking. If that's the research hypothesis, remember that your null hypothesis has to be the complete opposite. So the complete opposite of that, the complete opposite of smashed into is greater than hit, is that smashed into is less than or equal to hit. And that's your research and your null hypothesis. All right, so the next thing is to look up our Z critical. For this is our line in the sand, and for this, we need to know what our alpha is. So what you can do, especially on the, I would recommend this for all your hypothesis tests. Just take some time, use that scrap paper that I'll be using as a sign-in sheet. Draw out your distribution. This is going to be your comparison distribution, and it's going to have a z-score of 0 as the mean, and a standard deviation equal to 1. And just to be clear, your comparison distribution has that mean of 34 in this case, and a standard deviation, I believe it was 2.59. And this is what you want to compare your sample to. But because this is not in your appendix in the textbook, we need to take this and transform it into a z-score. So this is just a z-score transformed version of the comparison distribution. This we can look up. So we want a one-tailed test. We want to know if there's an increase. So we are going to test and put all of our alpha into the tail that indicates an increase on the greater side. And that's your entire alpha level. And for this test, it was an alpha of 0.05, which is 5%. So we need to look up the critical Z value for that. So what we do is we go to our unit normal distribution table in our textbook. I am going to go to my screenshots of that in my PowerPoint, and we need to find 5% in the tail. So we go to our unit normal distribution table, we find the proportion in the tail, make sure that you're looking in the right column, and then you just scroll down and scan until you get the closest value to 5% that you can find. For the exam, either the 5.05% or the 4.95% will be acceptable, but in this case, we'll use the 5.05. That's a z-score of 1.64, so that is our cutoff score. That's our line in the sand. And we enter that in, and for the one-tail test, make sure that you enter in the correct sign as well. So in this case, we're looking for an increase, so it's positive 1.64. But if the question was looking for a decrease, that means the tails on this side, it would be a negative 1.64. So for the one tails, that's important. So this time we're going for increase, that's a positive 1.64. And then we have to calculate the z-score for our sample. So we have a sample mean of 40.8, I believe it was. And we know on the comparison distribution that a mean of 40.8 will be somewhere over here. Because if that's 34 miles an hour, then somewhere over here is going to be 40.8. But again, we don't have this comparison distribution in the back of our textbook. So we need to take this 40.8 and transform it into a z-score so we know where it is on this z-score transform comparison distribution. So for that, we use our formula for z-score, and we have our sample mean minus the mean of the comparison distribution, all divided by the standard deviation of that comparison distribution. So we go back up to our question here, and we have a mean of 40.8 miles an hour. We got a comparison, we got a sample mean of 40.8 miles an hour, comparison distribution mean of 34, standard deviation of 2.59. So you can put that directly into the answer cell here. So we have our, we do our formula, open up the parentheses so that we know we do this top part first. So our sample mean is 40.8. Subtracted from that, our comparison distribution mean of 34, and all of that divided by 2.59. We hit enter, and we get a sample z-score of 2.63. So what that means is that if this is 0 right there on our z-score transformed comparison distribution, and we go, this is about 1 right there, this is 1.63 right there, this is about 2, this is 2.63. This is a marker that doesn't work. Let me get one of my own. So 2.63 is somewhere here, and that's where our sample mean ended up. So our sample mean has crossed the line, it's crossed over, it's gone beyond our cutoff scores, and this is one thing that I would highly recommend you do, especially in the higher pressure exam situations. Once you have all of this figured out, once you have done like 95% of the work, go to your lecture notes and check what you do in this particular situation. Because these two slides here let you know what to do. And just as a warning, I have seen many students get step 1 correct, step 3 correct, step 4 correct, and they went the wrong way on step 5. So until it becomes very automatic, I highly recommend just have these two slides here ready to go and waiting somewhere that's easily accessible. And just take a look, and it says if the sample z-score is beyond the cutoff z-score, beyond means it's crossed over into the tail, so the sample z-score has gone beyond the cutoff z-score. So what do? I accept the research hypothesis, I reject the null hypothesis. So we go back here, and we're accepting the research. So we delete whatever we don't need, which is the reject. And for the null hypothesis, has to be the complete opposite. And we scroll on down, and we have all of those correct. So this, again, will be exactly how it's graded. You got your null hypothesis correct, you got your research hypothesis correct, and did you get a different conclusion for both? Yes, and that's going to be worth full points. So that's an example of the one-tailed hypothesis test from start to finish, and that is exactly what you'll be needing to do for half of your exam. Hypothesis test just like that. Mm-hmm.
You said the comparison distribution won't be given to us in bold.
Yeah, so rather than having the comparison distribution isolated like this outside of the paragraph, it will be within the paragraph.
Oh, so then 2.59 will be, or it's like a,
The numbers will be given to you for sure,
okay.
but it just won't be big and bold like this. It'll literally be like this. The estimates of speed for the population of students is a mean of 34 with a standard deviation of 6.34. The comparison distribution is then a mean of 34 miles an hour with a standard deviation of 2.59. So it'll be the same as it is here in the text. And your challenge in the exam is going to be to remember not to use the population distribution, use that comparison distribution. Because the population distribution is a distribution of individuals, and it is only fair to compare an individual to a distribution of individuals. As soon as you have a sample, like we do, 15 college students, it is unfair to compare the score of 15 students to a distribution of individual students. So we need to compare it to a distribution of samples of size 15, and that's what your comparison distribution is. It's your distribution of sample means. All right, so that was the one-tailed test, start to finish. All right, so if there's, until I guess there's another question, a couple of things to, I'll just point out. Number one, half of the exam is going to be doing exactly this. So whatever kind of notes you need on the 5 steps, prep those for yourselves ahead of time. Once the exam starts and you get to question 4, which is where the hypothesis testing begins, pull out your sheet, lay it down in front of you and say, all right, step 1, I do this, step 2, I do this. Completely fine in that regard. Definitely check the slides on that step 5. I would recommend, even if you're confident in this, maybe just for the first 1 or 2, check your answer against step 5, because I have seen so many students just drop the ball right at that level, and I think it's a score of 16.33 out of 20, and I know exactly what happened when I see that. So don't let that happen to you. It's literally the least kind of involved thing to do, and yet that just because it's got that double negative type of structure, definitely check with the slides there, just as a double check. And then the last thing that I'll mention at this time is be very careful when you're doing your two-tailed test and you're splitting up your alpha levels. So when you're doing your two-tailed test, you take your alpha level and you don't get to put it all into one side. You have to take your alpha level and you have to split it up into the 2 sides. So for an alpha level of 0.05, that's a 5%. So you're looking for 2.5% in one side, half of your alpha, and 2.5% in the other side. I have noticed occasionally when people deal with alpha levels of 0.01, right? So if there's an alpha level of 0.01, sometimes students will make a mistake with this. So definitely, whenever you're dealing with your alpha levels, remember that your unit normal distribution table is not listed in terms of decimals, it's listed in terms of percent, right? So this is 5%. So rather than listing 0.05, it lists things as 5%. So I would highly recommend that as soon as you see your alpha level, just transform it into a percent version, right? We report it this way because this is the way APA has decided. Psychology is going to report alpha levels. But just for your own sake, change it into the percentage form, because I have seen some students, it doesn't happen as often, but you definitely don't want it to happen to you. I've seen some students look at this and say, all right, it's 0.01. It's a two-tailed test. So I got to split this into two. So 0.01 divided by 2, that equals 0.05. That's wrong, right? We're not used to dividing decimals usually by 2. So it's not 0.05, right? We're missing a 0 there, but I've seen it happen, right? And then that messes up the entire rest of your hypothesis test. So that won't happen if you say to yourself, all right, this is 0.01, that's 1%, and if I got to divide that by 2, then I get 0.5%. All right, let me go to the uninormal distribution table, and I will find this 0.5% wherever it is in that table. So those are just two of the pitfalls that I have noticed before. The dividing of the 0.01 done incorrectly, but definitely, for the one-tailed, for the two-tailed, just double check your final conclusions at least once. And it's not, if you have the slides prepared, you're going to have more than enough time to do this exam. If I was to do a speed run on this exam, again, it would be like a 20-minute, tops. So even if you take 3 times as long, right, which is a large estimate, you still will get this done in an hour. That leaves you a nice, comfortable 15 minutes to find those 2 slides just to double check to make sure that you don't lose those points. So make sure that you're doing that, and also use your scratch paper, draw your distribution out, and draw where your mean ends up, your sample mean ends up, and that just kind of offloads all that kind of load on your working memory and allows you to think about other things so that you don't make these little silly errors. Because from what I've seen and the questions that many of you have been asking me, you have the strategy down. You kind of understand the process. Some of you have got the logic behind it, which is great. Some of you don't, but you can definitely do a hypothesis test, which is exactly kind of where you need to be at this point. So the only thing I think that's going to trip up many of you are those little errors. So as much as you can, check your slides for step number 5 and transform your alphas into percentages before you go consult that unit normal distribution table.
Can you do a problem like probability starting from percentage?
Okay. So we're going to do a question now where we start with a probability and go to a raw score. Okay. So we'll, let me think, start with the probability and go to a raw score. Okay. Okay. We'll do this. So underweight is lower 30% of the population if the average weight for a person of age, we'll leave this ambiguous because I don't know average weights, is 140 pounds with a standard deviation of, let's go, 10 pounds. What weight is the cutoff for underweight? All right. So the first thing to realize whenever you read a question like this, it falls into one of two categories. You are either given a percentage and they're looking for a raw score, or you are given a raw score and they're looking for a percentage. So the first thing you want to do is decide which one of those it is. So in this case, we're starting off with a percentage, and it lets you know underweight is a lower 30% of the population. What weight, what raw score is the cutoff for being underweight? So once you have that info, there is, again, a series of slides that has this information, I believe. Yep. So there is a series of slides that has this information spelled out. So this is the one starting for a raw score. This is the one that you're starting with a percentage. Those are your 5 steps. So when you're doing your exam, again, great resource. Just have these slides somewhere ready. Maybe make your own PowerPoint file where you just copy and paste these so that you have those ready as well. So just for consistency, I'll follow this this in your textbook. So the first thing you want to do is draw your normal curve. And this is, again, a theme because there's a lot to keep in your mind. So why not unload as much as you can of that? So you draw your normal curve, and you want to know for an average, the average weight is 140. So that's your average right there. And we want to know what is the cutoff for being underweight. So there is the cutoff. This is the population that would be considered, the proportion of the population that would be considered underweight. And what area of the curve is that? Well, that is 30% of the curve. Now, I've clearly drawn this wrong. That is not 30% of the curve. It doesn't matter. It's in the right area. It's going to help me out later. All right, step number 2, we then go and we make a rough estimate. So for the rough estimate, we go back to this table over here. Now, you do not have to use that, but again, it's just your own. I won't be asking you for a rough estimate. I will just be asking you for the final calculation. But just to kind of double check this, so the rough estimate here, we need to have at least 30% in this area here. So you can see that from -1 on, that is 16%. And you can see that from 0 on, that is 50%. So if we had a cutoff of 0, that would be 50% of this distribution. If we had a cutoff of 1, that would leave us with 16% of the distribution. So we're going to be somewhere in between that. So whatever our cutoff score is, it's going to be between -1 is going to be greater than -1, and it's going to be less than 0. So again, this is just a way to ensure that you don't read the table incorrectly. That is our estimate of what the range should be. This is our drawing of what the range is going to be. So now we are ready to go to the unit normal distribution table. Now, let me see. Just to take this from start to finish, let me get that textbook up. All right, so this is clearly something you would do while you were waiting for the exam to begin. But what you want to do is have your Pearson eText open and ready to go. And this table that we're looking for is going to be in the appendix. So we go to the table of contents, and we go down to our appendix. All right, and then we have our tables here. So this is when it really gets important to have this drawing, to have that estimate, because we want one of these columns, right? We want one of these columns over here. And in this case, we clearly are dealing with a tail. So we want a percentage in the tail. And what percentage? Well, we labeled it. We clearly want 30% in the tail. So we look in the column that says percent in the tail, and we just start scrolling down, scrolling down, scrolling down, until we get to the one that is closest to 30%. Now this one here is 30.15. That is closer than 29.81. This one is 0.19 away. This one's only 0.15 away. So once we find where that is, we go across to the z-score, and our z-score, this question mark over here, our z-score is equal to 0.52. So let me just bring that right there. All right, so percentage in the tail, that's the closest we can get to 30.15. Go over to the z-score, 0.52, that's our z-score. So this cutoff score is minus 0.52. Remember, z-scores in the table are only positive because they didn't want to duplicate the negative side, but it's symmetrical. So we got to remember that's minus 0.52. And then once we get that number, we just double check it against our estimate. So minus 0.52 is less than 0, but it is greater than -1, so it's good. We didn't read the table incorrectly. That's the z-score that we that is the cutoff. So finally, what we need to do, the final step here, is we don't want to report a z-score. We want to report the actual raw score. So we have our z-score of minus 0.52. We have our mean of 140 pounds. And we have, go back to the question, a standard deviation of 10 pounds. So then we get our equation for the raw score equals your mean plus your z-score multiplied by the standard deviation. So we have a mean of 140 plus a z-score of minus 0.52 multiplied by our standard deviation of 10. So we'll pop that in here. So this equals our mean of 140 plus negative 0.52, and all of that multiplied by 10. Let me zoom in on that. There we go. All right, so once again, let me do that because it was not that big before. So 140 plus negative 0.52, because that was the z-score that we got. All of that multiplied by a standard deviation of 10. And for this age group, if you are 134.8 pounds, you are considered underweight. So that is the cutoff for underweight. That is our final raw score.
Do one the other way?
Sure. So let's say with let's stay with the current example here, and we will continue on with that average weight for a person example here. So yeah, the average weight for a person of age XXX is 140 pounds with a standard deviation of 10 pounds. What percentile would a person be in if they weighed 155 pounds? All right, so what percentile would a person be if they weighed 155 pounds? So once again, first thing you want to do is make your decision, which type of a question is this? So in this case, we have a raw score being given to us, and we're being asked for a percentage. So this is the opposite case. We're starting with a raw score. We're being asked for a percentage. Step number 2 is always going to be draw your distribution. So we have the same population distribution here, but now we're asking for a different section of it. So once again, this doesn't have to be to scale, doesn't have to be a nice looking bell curve. It just needs to function. So what percentile would a person be in if they weighed 155 pounds? So that's 140. 155 is going to be on this side. We don't really need to know where it is. We'll just say there it is right there. And then the percentile that you're in, be very clear on what a percentile is. If you have to Google it during the exam, Google it during the exam. If you have to look it up in your textbook, look it up in your textbook. But the percentile that you're in is how many people are at your score or lower, right? So that is the percentile that you're in. So the percentile here, the area of the curve that we're interested in, are the people that are at this level or lower. So the proportion that we need to find is this entire area over here. And one last thing that we'll do before we start taking a look at our unit normal distribution table is that this area here, whenever it takes up over half of your distribution, you're not going to be able to find this corresponding area in your unit normal distribution table. So the thing to realize is that if it takes up over half of your distribution, then the part of it that's on this side of your mean, that is 50%, because it's half of your distribution. So really the question then boils down to, what is this area right here? So we don't have to do any work to figure out what is this part of it, because that part's 50%, it cuts it right in half. So now the question becomes, what is that area of the curve? And then we go and we start taking a look at our answer. All right, so just for consistency purposes, when we're starting with a raw score, we drew our normal curve. We want to convert our raw score to a z-score. So one of the nice things about going from a raw score to a percentage, going from a percentage to a raw score, is that you know you're going to have to deal with z-scores. So if you complete your question and you have not gone to that unit normal distribution table, something went wrong. So you're going to need to deal with z-scores. So look for that. And the first thing we're going to do here is we're going to convert our raw score of 155 into a z-score. So this time we have the raw score, which is 155. We have a mean of 140. We got a standard deviation of 10 pounds. We get that from the question. So once again, if you need information, it's going to be in the question for you. So we got that in the question. We have to convert this to a z-score. we use our formula Z equals your raw score minus your mean, all of that divided by your standard deviation. So we got 155 minus 140, all divided by 10. And that's going to be 15 divided by 10. So that's going to be 1.5 is our Z-score. So that cutoff score, let me kind of do this weirdly here. So this distribution that we're working with, we got to convert it to a Z-score. So that 140 converts to a Z-score of 0. That standard deviation of 10 converts to a standard deviation of 1. And this score of 155 converts to a Z-score of 1.5. So 155 minus 40 is 15 divided by 10. That's a Z-score of 1.5. So now, once again, we know that this is 50% of the curve, and we're once again looking for this area here in order to complete the question. All right, so we draw our normal curve. Once again, we want to make a rough estimate just as a double check. So once again, you will not be graded for the rough estimate, but just to kind of make sure that you're not looking at the wrong area of the curve. All right, so we'll blow that up so it's a little bit bigger. So we have a Z-score now of 1.5. Z-score of 1.5 puts us, Z-score of 1.5 puts us right there. So the area that is below a Z-score of 1.5, because that's what we want, the area below. An area that is below that is going to be less than 34 plus 34 plus 14 plus 2. So it's going to be less than 80%. So the percent that we're looking for is going to be less than 84%. Sorry. It's going to be less than 84%. And the percent that we're, sorry, I got that backwards. See, this is why you want to draw it up. So the percent that we're looking for is going to be greater than 84%. And the percent that we're looking for is not 2%, right? Not, sorry, a Z-score of 2 is right about there. So it's not going to reach this far. So it's going to be less than 14 plus 34 plus 34 plus 14 plus 2, which is 98%. So we use that to make our estimate. So the percentage that we're looking for, when we look it up in our table, should be between 84 to 98%. Again, you won't be asked to do that on the exam, but it is a good thing to do just to make sure that you're not looking at the wrong area. All right, next we look up the percentage associated with the Z-score on the normal curve table. So this is actually a good thing that we chose this one, because you'll notice that nowhere on these is more than 50% of the table colored in. So that's where we remember that we can divide it into this area, which is 50%, and this area between our Z-score and the mean. So this is all that we need to figure out. And you'll notice that that is this column right here, and it's also this column right here. So now what we're going to do is we're looking for the information that we have, which is a Z-score. We're looking for a percent. We have a Z-score here. So we're going to go to our column here of Z-scores, and we are going to search until we find that Z-score. It's not on that page right there. Go to the next page. Don't quite make it there. Go to the next page. 1.46, 1.47, 1.48, 1.49, 1.50 right there. And then we ask ourselves, which one of these two numbers is the correct one? Well, this column matches the picture that we drew. So that area is 43.32%. So this section right here is actually 43.32%. All right, so our picture helped us look at the right area. For the entire percentile, we now have to add in that 50%. So 50% plus 43.32% gives us a final total of 93.32%. Last thing we want to do, once we calculated or once we looked up that percentage, last thing we want to do is we want to check our answer against our rough estimate. And 93.32% is greater than 84 and less than 98. So we know that we've done that correctly, gives us extra confidence, and that is the final answer. If you weigh 150 pounds in this fictitious population, you would be in the 93rd.32 percentile of the population. So basically 93% of the population weighs less than this 155-pound individual. All right, so you will have one question that is starting with a percent. Find your raw score. You will have one question on the exam. Start with a raw score. Find your percent. So hopefully this cleared up that for anybody. And again, if you at all are kind of forgetting or worried about forgetting the steps, have these slides ready to go. Once again, make up your own, between now and the exam, make up your own PowerPoint file that you can just load to a USB or however else you can access to, upload it to your Google Docs or whatever, and have it filled with the slides that you need in order to jog your memory so that you can do this. Because another thing sometimes that I notice students doing is looking through the uploaded Canvas slides. And I made those slides, and sometimes I have trouble finding them when I'm looking through, my USB, when I'm like, oh, which one did we take a look at the normal curve in? Was it this one? No. Was it this one? No. And that's all time in the exam that you could be spending doing other things. So prep your open book materials, have it all ready to go, and save yourself that little bit of time just in case you need it.